Hi everyone, this video is for lesson 6.1.3, Probability Distributions of Discrete Random Variables. We are going to be looking at question 10 located on page 7 of your lesson booklet. If you do not have your lesson in front of you, what I would encourage you to do is please pause the video and grab it so that you can follow along with me. To begin, the question reads, according to the Social Security Administration period life table, the probability that a 70-year-old male will die within 1 year is about 0.018. So that seems pretty important to me. So I'm going to go ahead and write that down. So probability 70-year-old male dies within 1 year is going to be equal to 0.018. Continuing to read on, it says the cost of a $10,000 life insurance policy for a 70-year-old male from one insurance company is about $540 per year. So a $10,000 life insurance policy for 1 year costs $540. We are going to be investigating a client by the name of John, who is a 70-year-old male, and he's gone ahead and he's taken advantage of this life insurance policy. So let's begin with the following. We're going to look at Part A. Part A reads, how much money did John pay the insurance company? Well, again, reading comprehension or going back to the information that I've kind of boiled down from the narrative, we know that John pays $540. Of course, there's a little bit more to the question, so the follow-up question is, if he dies this year, again, a super cheerful thing to think about, how much money will the insurance company pay his beneficiaries? In other words, those people who would receive the funds. So maybe it's his significant other, his spouse, his children, siblings. We don't really know John's life situation, frankly, I guess, since he's going to be dead and within the year, I guess we shouldn't get too invested. So we would note here that the insurance company will pay $10,000. Again, pretty straightforward reading comprehension. We pulled all that information from the narrative, and actually, if you were writing everything down in the way that I have in black, so basically summarizing it, we've been able to just pick those pieces of information out relatively quickly. So moving on to question B. If John dies this year, how much money will the company lose on this policy? So losing in this case is a little bit different than what they're actually paying. So in this case, what we want to note here is that yes, the company did lose, I guess, $10,000, or they paid out $10,000. I should be careful with my wording. They paid out $10,000, but at the very beginning of the situation, John gave them $540. So this is just one way of answering the question. I'm choosing to use a negative value to indicate a loss for the company, and then I'm also including that positive as the gain for the company. So in this case, we find out that the company will lose $9,460. So if you approach this problem slightly differently and you did 10,000 minus 540, notice that you will still get the same solution, you'll just have a different sign. Again, if you were writing this out in words, you still would tell me that you're losing that money. So either approach is fine, just as long as you are clear what your final answer means. Okay, so again, yes, the company is going to pay out $10,000, but they got $540 of John's money at the very beginning of the year when he bought this policy. So they're not losing as much as you would think. They still have that $540. So let's continue to move on to part C. Part C is, what is the probability John will die within a year? Again, this is a reading comprehension question. We've noted that John is a 70-year-old male, and here we are specifically saying what happens if he dies within a year. It's going to fall on this probability. We're going to have it be equal to 0.018, or if you converted this to a decimal, we would, or sorry, not a decimal, if we convert it from a decimal to a percentage, we would find that the percentage would become 1.8%. So the good news for John is that it's more likely that he's going to not die within the year. There's a slim chance that it can happen. Again, it still can happen, but it seems like it's more likely that he's going to live. So good news for John. So continuing to D. If John lives for the entire year, how much money will the company make on this policy? Again, we're kind of back to that reading comprehension. So John doesn't die, so the insurance company doesn't pay out. So how much money did the company actually end up making in profit? Well, in this case, we know that it costs $540. The insurance company isn't going to come back and say, sorry you didn't die, here's your $540 back. Notice we're talking about an insurance company and not a hit company. So what we want to note here is that the company gains $540. So if you think about it with regards to insurance, the company wants John to stay alive so that they don't have to pay out. They just want his money. So let's continue on. Letter E, what is the probability that John will live for the entire year? So again, what you want to think about is, let's think about all the possible events that could happen for John. So let's talk about all possible events. We examined one of them already. We had said that one of them was John dies. Well, really, if you think about it, what's the only other option if we're talking about John's life here? He's either going to die or he's going to live. So if we know that John lives, we're essentially going to be investigating the complement here. So to be a little bit clearer, the probability that John dies plus the probability that John lives, this should come out to 1, or in other words, 100%. We've examined every possible outcome that could happen with regards to his life. Okay? John is either going to be alive or John is either going to be dead. Please try to refrain from rabbit holing and trying to come up with all these weird scenarios about how maybe John is on life support or something along those lines. We want to be kind of a little bit broader. He's either going to be considered alive or he is considered dead or declared dead. Well, we know in this case that the probability that John dies is going to be 0.018. Say we don't know the probability of John living, and technically we don't. Maybe we could use a variable here right now just to hold its place. But we know that this is going to be equal to 1. This is just one way of looking at the problem. So in this case, what I would do is I want to isolate x, and I want to remove that probability from both sides to get x alone. If we do the subtraction, we get 0.982, or in other words, there's a 98.2% chance that John is going to live in that year. John is probably super relieved. Another way of looking at this problem would be, again, we're looking at the complement, so the opposite of John dying, or all the other possible events that other than John dying. We could go ahead and just start off with 1 minus the probability that John dies. would result in the probability that John lives. So this would be 1 minus 0.018, which again would give you the result of 0.982. This isn't a coincidence. These are actually two different ways of arriving at the same solution. And if you don't quite see it, what I would encourage you to do is pause the video and really examine what I have written down here. So hopefully you're feeling pretty comfortable. Let's go ahead and move on to question F. Okay, I'm going to clear this out and get rid of any stray marks here. Okay, so question F. Question F reads, let X represent the amount of money that the insurance company will earn this year. So again, X is going to be amount of money earned by the company this year. From John's policy. When the company loses money, the amount of money earned is negative. So we're going to construct a discrete probability distribution for X by completing the table. So bear with me as I create this table, or maybe fast forward, I don't know. Okay, here's my table. So here is the amount of money earned by the company underneath we have the probability, and I'm just going to write that as P of X to save a little bit of time. And here, one option would be John dies, and as we had noted, there were only two outcomes here. John is either going to die or John is going to live. Okay. We've actually created all of this information in our previous work above. Okay. So the amount of money earned by the insurance company when John dies, well, we know that in this situation, the company loses $9,460 in that case. Because again, yes, they're getting that $540 from John, but when he dies, he's getting that $10,000 payout. And again, as we had noted, they're really only losing $9,460 in that situation because they still get to keep the $540 that he gave them. If John lives, well, the good news is they get a positive $540. They get to keep that money. We had also noted previously that the probability of John dying, maybe to his relief, is only 0.018. And when we investigated question E, which dealt with the complement of the probability of John dying within the year, we found out that the probability of him living was 0.982. If you recall from our studying of complements, if we added up the complement of the probability that he dies, so if you add up the probability of John dying with the probability of John living, it should sum to 1 or 100%. Okay, so let's keep going here, everyone. We're almost there. So question G, what is the expected value of the amount of money that the insurance company will earn this year on this policy? Okay, so remember that the expected value, we use the Greek letter mu to denote it. And in order to calculate the expected value, we're going to take every possible outcome, so those possible values, and we're going to multiply them with their respective probability. So in this case, I would have negative 9,460 times 0.018 plus a positive 540 times 0.982. If we were to go ahead and calculate this, we would get the following. So negative 9,460 times 0.018 is equal to negative 170.28. And we're going to add that to the product of 540 times 0.982, which gives us a positive 530.28. Again, what I want you to remember is keep PEMDAS in mind. Note that we have to do multiplication before we do addition. So when we add this up, we're going to get a positive 360. Okay, so we're basically saying that because we have a higher chance of, as the insurance company, we have a higher chance of keeping that $540. So again, John wants to live, and essentially the insurance company wants him to live, because then they get to keep $540 and they don't have to pay out a policy. We also see that the probability of John dying is so little. So even though there is that risk of having to pay out $9,460, really, because it's so little, that's why our value shrinks so significantly. So our expected gain as the insurance company is $360. So let's move on to our last part of the question. It's a lot of work behind this one. So letter H, interpret the expected value of the amount of money the insurance company will earn this year. So we've kind of discussed it, but what I would say here is that the insurance company has an expected value or an expected profit. Let's go a little bit more specific. Has an expected profit of $360 from John's policy with them. Okay, so again, this is their expected profit, or this is their expected average profit. So maybe let's add that little change here. So average profit, because again, our expected value deals with the mean or the average. So again, in this situation, maybe you're asking yourself, but how could they stand to make $360? If he dies, they're losing $9,460, or if he lives, they get to keep $540. So again, we're just looking at the average here. And this actually will inform the insurance company. So if they kind of calculated the expected value and they found that it was more likely, or that the average was negative, meaning that they would have a loss, they might decide to either increase the cost of the policy, or maybe they wouldn't offer the policy at all for 70-year-old men if that probability of them dying within a year was higher than 0.018. So essentially what you kind of want to think of is, with regards to H, it's more of like being used as a decision factor for the insurance company. Do they want to offer this? Because they obviously don't want to offer policies where they run the risk of losing money, or it's likely that they will lose money. So I hope that this has helped out. If you do have any other questions, please let me know. And I guess that's it. Thanks.